Okay, sorry about cutting this video. For some reason or other, the video stopped recording. So this will carry on from this point. Okay. So at this point we have established which ratio to use, and we're going with the fact that sine of angle A is 94 over BC, which is unknown, is equal to sine of angle B, which is 62, over AC, which is unknown, is equal to sine of angle C, which is 24, over AB. And that is what they want us to calculate, AB. Okay. So that is the ratio needed. We have, nope, I think we AC had to be replaced. Okay. AC was a length of 7. Okay, just take a AC was 7. Okay, so as we said there, we're going to work with that there. So what we do is we cross multiply, so it will be AB sine 62 degrees is equal to 7 sine 24. So AB simply AB simply 7 sine 24 over sine 62. Okay, so let's put that in our calculator. So it will be fractions, say 7 sine 24. I don't know why the calculator is looking like this now, over sine 62. Okay, so that's 3 comma 2. 3 comma 2 centimeters. Okay. Okay, so now we're looking at number 4 of exercise 10.3. The question says calculate the length of GH. So GH is this length here. Okay. So again we say sine. Okay, so we say GH over sine of angle I is equal to GH is going to be HI over sine of angle G is equal to HI. Okay, we got HI. HG we have GI over sine of H. Okay, so that's the known side, so we need to know that angle there, okay, to apply the sine rule. Okay, so for angle G, we're going to say it's going to be 180 minus 47 degrees minus 33 degrees. Okay, that's going to give you and just checking, it's 180 minus 47 minus 33 is 100 degrees. Okay, that's angle G. So that's enough information now to calculate GH. Let's see. GH is what we're calculating. So GH over sine of angle I, which is 33 degrees, is equal to HI, which is 12, over sine of angle G, which is 100. You can write this and its information that you know down there, but that's not going to help us in any way. Okay, so we can just leave that out. Alright, so what we do now is we cross multiply, or we can just take sine 33 up, So it's going to be GH is equal to 12 sine 33 over sine of 100. Okay. So we just need to enter that into our calculator. So fraction 12 sine 33 over sine 100. Okay. That gives you an angle of a length, sorry, not an angle, a length of 6,6 centimeters in this case. Okay. Okay, in number 7, we are told in triangle, select the color, in triangle VWX. We can say that VW is 5 centimeters, the WX is 9 centimeters, and angle X is going to be 32 degrees. The question says calculate the size of angle W. So we know that sine of W over lowercase w is equal to sine of angle V over lowercase v is equal to sine of x over lowercase x. Okay, so we fill in what we have. So it's sine W, which is unknown, and that's what we want to calculate, over xv, which we don't have. Okay, we can just say lowercase w as well. It's the same thing. Sine of v, which you also don't have, over the length of v is 9, is equal to sine of x, which is 32 over 5. So looking at what we have here, okay, we have, that's a known ratio, so we're definitely going to use that, and that is, this ratio is shorting one variable, which is v. We can't go straight into w because we don't have this length here, otherwise there's two unknowns there. So we're going with this information. Shall we cross multiply, or we can just take 9 up? Okay, so that is sine, angle v is going to be 9 sine of 32 degrees over 5. Okay, so then we take arc sine of this answer that you're going to get for 9 sine 32 over 5. So let's work that out. It's going to be 9 sine 32 degrees over 5. That gives us 0, 9, and the number carries on, of course. So you press arc sine, shift sign of that answer. Now remember, answer is the last answer calculated on the calculator. So your angle V, works out to be 72,5 degrees. Okay, 72,5 degrees. But remember, now the question was, what is the size of angle W? Okay, so for angle W, we're going to say that to work out angle W is going to be 180 degrees minus 72,5, which is this angle there, angle V, minus 32 degrees. So again, we put it in our calculator. So it's 180 minus answer calculated minus 32 degrees gives us 75,5. The angle there, 75,5 degrees. Okay, I think that is fairly straightforward. Okay, so now we're looking at number 10. Just get this here. Number 10. So we said in triangle DCN. So in triangle DCN. And there's not an N, does it? We are told that DN is 15 centimeters, CN is 17 centimeters, and angle D is 52 degrees. Okay, so angle D is 52 there. Okay, the question says solve triangle. So to solve the triangle, we must calculate all the unknown sides and all the unknown angles. So we say sine of angle D over NC, or lowercase d, is equal to sine of angle C over lowercase c, which is ND, is equal to sine N over lowercase n, which is DC. So let's fill in what we have. So we have sine of angle 52 over NC, which is 17. There's my known ratio. It's going to be sine of angle C, which I don't have, ND, which is 15. So there, at this point, we can calculate the angle. We can calculate the angle C. Can you see that? Because we have that 15 we have, so we can calculate angle C. Okay. Go back to the red. So sine of N, which I don't have, and DC I don't have. Okay, so this is cross multiplier. We can just take that 15 up. Okay, but just taking the 15 up, we're going to sort out the problem we have there by making sine C first the subject of the formula to isolate that. So it's going to be sine of angle C is equal to 15 sine 52 degrees over 17. So we put that in a calculator. We get 15, first fraction, 15 sine 52 over 17. That gives us so angle C, arc sine of angle C, arc sine of this ratio here, which is 0,695. 0,695. Of course, the number carries on. We got arc sine of that answer. So arc sine of that answer, which is the last answer, calculated, give us 44,1. Okay, so let's just fill this in here. So it's 44,1. Okay, so in other words, at this point now I can calculate N. Not so? So I can go with sum of triangles. So from there, I'm just going to go here. So angle N is equal to 180 minus 44,1 minus 52 degrees. Okay, so that's 180 minus 52 minus the last answer calculated, which is 44.1, gives you 83,95. So it's 83,9. Okay, there's 83.9 degrees. So I'm going to fill that in here. So it's 83.9. So the only thing that still needs to be calculated here now, of course, is going to, so we got now angle N, we got, so let's just calculate DC. So again, I'm going to go with the known ratio. So I can say sine, let's change our color here, let's say sine of 52 degrees over 17. Remember, this is coming from here now. Okay, is equal to sine of N. Now I'm going with this here. Okay, I'm missing now. So it's going to be sine of 52 over 17 is equal to sine of angle N, which I do have, which is 83,9 over DC. Okay. Again, I could have gone and gone the other way around, and I would have had DC as a subject of the formula. So what I do is I cross multiply. So you got DC sine of 52 degrees is equal to 17 sine 83,9. Okay. So DC is equal to 17, so I divide both sides by sine 52, sine 83,9 over sine 52. Okay, so let's put that in our calculator. We now get, remember 783,9 is the answer. Okay, so it's going to be 17 sine, every time I want to type sine on the keyboard, close brackets, over sine 52. Okay, that gives me a length of 21,5 centimeters. Okay. Okay, so now we're looking at the ambiguous case of the sine rule. We are told that if the size of one angle and the length of two sides of the triangle is given, and the shortest side is opposite the given angle, then it is possible to draw two different triangles with the same angle given information. This is why this combination is called the ambiguous case. So note here, we are given the smallest angle is opposite the shorter side, and the largest angle is opposite the longer side. Okay, that we know already. Therefore, if the triangle contains an obtuse angle, this angle will be opposite the longer side. Okay, then we are told in the third bullet that any triangle will have at most only one obtuse angle. So there's no way that it's a triangle that has two obtuse angles. Remember, obtuse angle is an angle greater than 90 degrees, but less than 180. So if a triangle have an obtuse angle, it can only have one. Okay, but there are triangles that does not have obtuse angles in it. Okay, and it's going to then be known as the acute angle triangle. Consider the following example. So we're going to look at the examples here quickly. Just cut this. Okay, so we are told this is the example on page 344. Okay, we are told solve triangle ABC. So that means to say calculate all the unknown angles and all the unknown sides. I'm not sure if I told you earlier on that at this point you had to complete all the unknown, all the angles, not the angles, but the sums that was not calculated in the video. You can at this point calculate or do exercise 10.3's remaining sums. Okay. Alright, so we are told to solve this triangle ABC, which means to say you must calculate all the unknown angles and all the unknown sides. And it's given that AB is 8, AC is 6, which is lowercase b, angle B is 48 point. Working correct to one decimal place. We can draw a triangle in two different ways as shown in the diagram below. So here we can have a triangle looking like that there, with the acute angle as angle C, or we can have an obtuse angle at angle C. Okay, can you see that? So it's acute angle or the obtuse angle. Okay, both would be correct. So unless they specify that the angles are all acute, or it's an obtuse angle triangle. Okay. Okay, so let's just write down what we have. Let's just get this here quickly. Okay, so it's going to simply be sine of A over A. Okay, is equal to sine of B over B is equal to sine of C over C. Okay. Let's check if this is in order. Yes. So for sine of A, angle A is unknown, so sine of A over A is equal to sine of 48 over 6, there's my known ratio, is equal to sine of C over 8. Okay, so at this point I'm going to calculate, I can calculate angle C. Okay, so I'm going to take 8 up, it then becomes sine of angle C is equal to 8 sine 48 over 6. So angle C is equal to arc sine of the story. Okay, so put on the calculator arc sine of, we've got 8 sine 48 degrees, close the bracket, over 6. That gives me an angle of 82,2. Okay, sine of 82,2. Alright, but remember that what did we say earlier on? The shorter side will be opposite the shortest angle. So for this here it could be an acute angle, but larger than 48 degrees of course, or it can be an obtuse angle. Okay, so angle C can be one of two things. Okay, if it's an acute angle, oops, if it's an acute, it will be that. If it's obtuse, it will simply be angle C is going to be 180, minus 82.2. Okay, which will then give us, remember why 180 minus, because that's in your second quadrant. So it's 180 minus that answer that was last calculated there, which is 97, 8 degrees. Okay, now if that's your obtuse angle, of course now this for angles, the third angle is going to be now one of two cases. Remember, it can either be obtuse. If it's obtuse, it will go with the side here, or if it's an acute, it will be that. So angle A, would be 180 minus 82,2 minus the known angle, which is 48 degrees. So I then say 180 minus 48 minus 82.2 gives us an angle of 49,8 degrees. Okay, so if that is 49.8, so remember we got 49.8 here and we have 82.2. Okay, so in pursuit of calculating A, I'm going to go with sine of A over A, so it's going to be this one here and that only. Okay, so it's going to be sine of 49.8 over A, which is what you want to calculate, is equal to sine of 48 over 6. Okay, so what I do is I cross multiply. So I take that up and that down and that up. Okay, otherwise you can cross multiply and then divide afterwards, that's no problem there. So A is equal to 6 sine 49.8 over sine of 48. Okay, let's put that in a calculator. So you're going to get fraction 6 sine 49.8, close brackets of course, over sine 48 and close bracket again, gives us 6,2 centimeters. On the other end, let's just change our color here. Okay. I'm just going to throw it here. Let me just see if I can do this. Right. I'm still new at this, so just bear with me a bit. So we have angle C here of 97.8. So now to calculate angle A, it's going to be 180 minus 97.8 minus 48 degrees. Okay, so let's put that in a calculator. So it's 180 minus 97.8 minus 48 degrees gives us an angle of 34.2. So it's going to be 34.2 degrees, which is this angle here, 34.2. Now coming back again to calculating A in this triangle, is going to simply be sine of A, say sine of 34.2 over lowercase a, is what we're calculating, equals sine of 48 over 6. Okay, I could have gone with the other ratio, but I think it's going to be the easier one. So A is equal to 6 sine 34.2 over sine of 48. Okay, so that gives us 6 sine 34.2 over sine 48. That gives you 4,5. So that's 4,5 centimeters. Okay. Okay, so now we're looking at exercise 10.4. I'm going to do a few sums of this exercise, and then whichever sums are left, or the sums that we haven't completed, please do that before proceeding to the next exercise. Okay. So in question 10.4, on page 345, we are told that, remember, the ambiguous case applies only to those questions in which the sides opposite the given angle is the shortest of the two sides. Okay, so that is very important to note here. Okay, when do we apply the ambiguous case? The only time we apply the ambiguous case is when the side opposite the given angle is the shortest. Okay, so let's look at question 1. In question 1, we are told that in each case solve the triangle. Solve the triangle means to say all the unknown angles and all the unknown sides. So if you're looking at this triangle ABC, so we got A, B, C. So AC is 9, AB is 5, and angle B is 65. You see again, AC, and I've marked it wrong. AC is 9, AB is 5, and angle B is 65. Okay. AB is 5, angle B 65. Alright. So what we have here, of course, is, okay, so that is 65. Just check something. Okay, I was actually hoping to choose a or to do a sum with you where the ambiguous case is being applied. But here it says here the ambiguous case can only be applied with the shorter side of the two. Just check here again. Which side is opposite the given angle is the shorter of the two sides. But if you look here, that is known, but that's not the shortest side. So the ambiguous case is not going to actually be applied here. Okay, so this is a straightforward one. So that's going to be sine of 65 over 9, which is a 9 ratio, is equal to sine of angle C over 5. So it's a matter of cross multiplying there. So sine of angle C is equal to 5 sine 65 over 9, and we take arc sine of that. So shift sine of 5 sine 65, that is over 9, give you 30,2. Like I said, as I said here earlier on, the ambiguous case is not going to apply. Okay, so it's 30.2 there. Then we're going to get angle A, which is 180 minus 30.2 minus 65. So it's 180 minus 65 minus that answer. Calculate in the previous question is 84,8. 84,8 degrees. Okay, and then to calculate BC, BC over, remember now we got angle A, which is 84,8. So it's sine of 84,8 equals 9 over sine of 65. Remember, going with that there. Rather go with what is known. So I'm going to just take that up. So we got BC is equal to 9 sine 84,8 over sine of 65. Put that in a calculator. 9 sine 84.8 over sine of 65. So that's going to give you 9,9 centimeters there. Okay, so we're going to choose now one where the ambiguous case is applied. Okay, so in number 1D, we are given in triangle GKH. So let's draw the triangle. So it's triangle GKH. Angle GH is 5 centimeters. HK is 9 centimeters. And angle K is going to be 32. So as you can see there, the shorter side is opposite the given angle. Okay. So in that case, we're going to use your ambiguous solution. Okay, or two triangles can be constructed there. Okay. So again, just to remind us, when do we use an ambiguous case? Can be applied only to those questions in which the side opposite the given angle is the shortest. Okay. You see, the reason for that is because if the side given opposite the longest angle, if that angle is given, the side opposite the largest angle, if that side is given, then if that angle is given as an acute, and then the whole triangle is acute triangle. Otherwise, if it's an obtuse, it would be given as obtuse. Okay? So which makes sense why if the given side is the given side is the shorter of the two known lengths. Okay? People, if I had explained something incorrectly or there's an easier way of doing it, please contact me on that number. If I made a mistake as well, please feel free to contact me on this number. Okay. So let's go with what they want now. So they want you to solve the triangle. So we're going to say sine of h over h is equal to sine of g over g is equal to sine k over k. Okay. So we fill in what we have. We have sine of h. We don't have angle h. We don't have the length of h either. So we go sine of g, which we also don't have, over 9 is equal to sine of k, which is 32 over 5. Now some of you can already see, okay, I'm going to go with that and that there. So they leave this out. There's no problem with that as well. Okay, you could have done that if you are picking up the rules already as we are moving along. Okay, so in this case here I can then calculate g. Okay, so what do I do is I cross multiply, or I just take the 9 up in this case. Okay, so only the 9 goes up. So angle G is equal to arc sine of 9 sine 32 over 5. Okay, so let's put that in the calculator. So you're going to say arc sine, oops, shift sine, arc sine of 9 sine 32, close that bracket, over 5. It gives you 72,5. So angle G is 72.5 degrees. Okay, but what did we say? This is going to be your reference angle. Right? Why? Because it can be one of two. It can either be obtuse or it can be acute. Okay, so if it's acute, let's go here. If it's acute angle, and then your angle G would simply be 72.5 degrees. Okay, if it's an obtuse, it's going to be 180 minus 72.5 degrees. Okay, which makes angle G, my handwriting, so it's 180 minus 72.5 gives me an angle of 107.5 degrees. Okay, so let's go with the fact that it's acute. If it's an acute angle, then angle H can be worked out as 180. Remember now, angle G is 72.5. Okay, so angle H, of course, sum of triangles. Alright. So it's minus 72.5 minus 32 degrees. Okay, so it's going to be 180 minus 72.5 minus 32 gives me an angle of 75.5 degrees. Okay, and then with that I should be able to calculate lowercase h. Okay, so h over sine 75.5 is equal to what was that? This here it was sine of 32 over 5. So it would be sine 32 over 5. Okay, so h is equal to, oops, remember I went the other way around. Okay, so this must be 5 over 32. Okay, over sine 32. So let's just take it up. So it's going to be 5 sine 75.5 over sine of 32, which makes h length. Let's just go here. So it's sine 5 sine 75.5 over sine of 32, 9,1. 9,1 centimeters. Okay. Otherwise, if it's obtuse, I'll just get this here. So I'm just going to cut the diagram. Okay, try one more time, otherwise I'm just going to leave it. Alright, so if the angle is obtuse, let's change my color here. If the angle is obtuse, then angle G now goes to be 107.5. Of course, obtuse angle, this looks like an acute, okay? So for angle H is simply going to be 180 minus 107.5 minus 32 degrees. Which then makes angle H, so it's 180 minus 107.5 minus 32 degrees gives me 81 over 2, which is 40.5. Okay, this angle here, of course, is 40.5. Now to calculate lowercase h, so h over sine of 40.5 is equal to 5 over sine 32. Remember, that was the known angle there. Okay, so we're just going to take 40.5 up, so it's going to be h is equal to 5 sine 40.5 over sine of 32. Put that in our calculator. It's going to be fraction 5 sine 40.5. I could have just pressed the answer because it's the last answer calculated, over sine 32 degrees. That gives me a length of 6,1. So h is 6,1 centimeters. Okay. Okay, so scanning through the remaining sums of 10.4 in number 2 and number 2 A to D and number 3, 4 and 5, there's not many ambiguous cases, so I don't want to do another one and then deprive you from experiencing this or being exposed to it on your own for the first time. So at this point I would suggest you go through 10.4, the remaining sums, and then let me know if you have any issues thereafter. Okay.